Hi, welcome back. In this video, we're going to take a look at the combined gas law. So we know that Boyle's law is equal to P1 V1 equals P2 V2. We know Charles' law is V1 over T1 equals V2 over T2. And we know Gay-Lussac's law is equal to P1 over T1 equals P2 over T2. And we can combine all of those together into one law called the combined gas law. So we have P1 V1 over T1 equals P2 V2 over T2. And again, this is an easy equation to work with. All that we have to do is rearrange the formula to solve for whatever missing variable we're looking for. One thing to remember is that temperature does have to be in Kelvin. So if you're given Celsius, you need to add 273 to that number. So let's try an example. Let's say that we have a syringe with a pressure of 1.02 atmospheres at 22 degrees Celsius, and we place that syringe in boiling water at 100 degrees Celsius, and the pressure increased to 1.3 atmospheres, and the volume was reduced to 0.224 milliliters. What was the initial volume? So first, let's write down what we know. We know P1 is equal to 1.02 atmospheres. We know T1 is equal to 22 plus 273, which is equal to 295 Kelvin. We do not know what V1 is. P2 we know is 1.23 atmospheres. T2 is equal to 100 plus 273, which is 373 Kelvin. And V2 is equal to 0.224 milliliters. Our equation is P1 V1 over T1 equals P2 V2 over T2. And we are solving for V1. So to get that by itself, I need to multiply T over to the other side. So I have P1 V1 equals T1 P2 V2 over T2. And then to get V1 by itself, the last thing I have to do is divide by P1. So V1 is equal to T1 P2 V2 over P1 T2. So now we can just plug in our numbers. Let's see. Volume 1 is equal to temperature 1, which was 295 Kelvin, times pressure 2, which was 123 atm, times our volume 2, 0.224 milliliters, over pressure 1, that was 1.02 atm, times temperature 2, which was 373 Kelvin. And Kelvin cancels out, atmospheres cancels out, we're left with milliliter, which is what we're looking for volume. You can plug all of this into your calculator, and for V1, you should get 0.214 milliliters. So we can easily solve for the missing variable if we know all of the others just by rearranging our formula. And one small trick, so if we have P1 V1 over T1 equals P2 V2 over T2, some people find it hard to rearrange the formula when we have a quotient. So we have T1 and T2 on the bottom of our fraction. And that can be confusing for some people to try and rearrange to solve for one variable. So if you don't like having a quotient, what you can do to write your law instead is just multiply your t's to the other side to just go ahead and get rid of that fraction. So you could also write your law as P1 V1 times T2 equals P2 V2 times T1, if that helps you when you're solving for any of these variables. If you're still struggling with any other gas laws, make sure and check out my channel. Thank you so much for stopping by.